Hello, fellow leaders of the web. I'm Nathan Tranquilla. TypeScript's structural typing has a semantic loophole. In this video, I'm going to dive into what that means. I'm going to show you an example of how this could be quite costly to you, and I'll show you a counterexample in a next generation web development language so that you can do better in your next project. Let's get into it. All right, so what is structural typing? Well, structural typing is based on the shape of the object. So we're talking about an object's properties and their types. And in TypeScript, it's statically checked. So that means at compile time, the shape is checked, but not the identity or the name or the semantics of what it is that you're defining as a type. And so that leaves in place a semantic loophole, which is what we're going to be getting at in the core of this video. All right, so let's talk about shape compatibility. So in this example, we have interface A and B. They share a common property, which has a type of number, and interface B has an additional property, y of type string. Now, when we create this object literal and assign it to B of type B, we can assign B to A with type A, and this compiles. And that is because B has the property X, which is the minimal requirement to satisfy type A's shape. And so the fact that variable B has a property Y is ignored. So this is what we're getting at when we're talking about shape compatibility at the heart of TypeScript's static checking. All right, so in TypeScript, there's no nominal distinction between two types that have the same shape. So in this example, we have an interface user and an interface det, and they have the same properties and the same types for the given properties. We can easily create a user with the type or the shape of user, and then we can assign user to det with the type det, and it compiles because it has the same shape, and TypeScript makes no distinction based on the type name, only the shape. So that's what we mean by structural typing. Now, here's one more nuance. So let's say that we have the same user interface and we create an object ID that has an additional property, which is the extra is true property. It's a Boolean property. So if we assign this object to user, it compiles, and the extra property is basically ignored. It satisfies the minimal shape of the user property. However, if we create an object literal under the user shape or the user interface, we get a compile error due to this extra property. All right, so now we are primed to get into the semantic problem that we've been getting at. So here is a costly example that gets at the heart of the semantic issue here. So let's say we have a user profile which represents, that has properties ID and balance representing their funds. And then we have a fundamentally different interface which has two of the same properties, ID and balance, but really what we're trying to indicate here is det. It has this additional property called due date. Now if we create a function called display funds, which accepts a user profile, and we pass in payment details, this compiles and it will display funds as $50 when really the input was det. So you can imagine how this could be a costly error to make. Now let's take a look at a counterexample in Rescript. So we have the same two types defined, user profile and payment details. We have a function to display the funds, and we have some mock API data. I've commented out the second to last stanza, but display funds on API data will not compile. There'll be a compile time error, and that's because the type payment details is fundamentally different than the user profile type. And so the last line we have the corrected example. Now let's go over line by line what's different about Rescript's static typing. So nominal typing. So we've defined two different types, and they are distinct, not because they are structurally different. It's because they're defined differently in the name. So user profile and payment details. Even though there's overlap in some properties and their types, these are two fundamentally different types in Rescript. And we get a compile time error. And this is just to reinforce the fact that there's no structural compatibility between the user profile and the payment details. So we're going to get a compile time error. Okay, so what can we do about this semantic loophole with TypeScript? What can be done? Well, you can start investing in a next generation web dev language. And you can go back and take a look at some of my other videos highlighting TypeScript's other failures in the type arena. And hopefully after looking through these videos, you will come to the same conclusion that I have, is that there is a next generation of web dev languages out there that we should start looking into. If you want to see how next-gen web dev languages can solve your web development problems, like, subscribe, and follow me on the journey. Bye now.